A very good evening to all of you. This is Yogendra from Forsk Coding School. And guys, welcome to our day 4, program on, a deep learning. So guys, so far, we have gone through first 3 days, right? And if you remember what we have done so far, on the day 1, we understood the basic concepts around deep learning, that what the deep learning is, and why we use deep learning, what are the use cases, and then we understood that when your data set is large, and generally data set becomes large in a case when your data is in form of images, in form of audio, in form of a video, or in form of a text. In those cases, most of the time data becomes large to handle, right? And that's where you need the deep learning. And we also understood the idea that why the performance, of the deep learning, performance of the deep learning is there, that, that is a much, but better than the performance of the ML if the data set is large. After this understanding, we started concepts around a neural, a network, that what the neural network is. And then we started this discussion that, a neural network is a layered architecture. Neural network has layers, and every layer has nodes, and these nodes are sometimes called perceptron as well. And every node may be represented this way, where it has an input, whether it has an output, where it has a weight, whether it has a bias, and it has a activation function with it, right? That was the case. And then basically on the second day, on the day 2, right? We talked about neural networks in much more details, and then we understood the concept that how layers are connected to each other, right? So how come the first layer is called as the input layer, right? And the layers in betweens are called hidden layer, and the last layer is called as the output layer. And then we got the concept that input layer, should have, the input layer should have a number of nodes equal to a number of features in the data. That was the case. And then we also understood the concept that how many nodes you should have in case of an output layer. And based on whether it's a regression problem, whether it's a binary classification or a multi-class, a classification, based on those scenarios, we were able to identify that what should be the right number of nodes in the output layer. And similarly, we had a rough number around the nodes in, right, nodes in hidden layer as well, right? So that concept is also known to us now, right? So that concept is also known to us now. And after that, we also understood various activation functions. If you remember, guys, various activation functions. As of now, we have discussed 3 activation functions. One was the ReLU, another was sigmoid, and third one was softmax. So we understood the functionalities of the activation functions as well. And we discussed that hidden layer uses ReLU, right? And on the output layer, that depends on the problem, right? That what activation function would be used on the output layer, it is dependent on the problem that we are trying to solve. If it is a regression problem, right, no activation functions required. If it is a binary classification, then sigmoid is required. If it is a multi-class classification, then a softmax is required. That was the case. And then we also understood that how the weights, right, how the weights are, initially weights are randomly initialized, right? And then what happens, our data progresses in the forward direction, right? And based on the prediction results, a loss function, compares, the predicted values with the right target values. and based on that we have a backpropagation, and backpropagation is done by optimizer, right? And the optimizer that we used yesterday was Adam. So optimizer is an algorithm which manages, the weights during the backpropagation. That was, that is there. So this is, how that is there. So uh, that was the concept. Now, after all understanding all the concepts related to artificial neural networks, this is basically your ANN, right? This is basically your ANN. And after understanding all the basic philosophies of an ANN model, yesterday, you know, uh, yesterday uh, we implemented a ANN model using which library, guys? What library we used yesterday to create an ANN model? Keras was the library for that, right? And if you remember what we have done in the yesterday's session, while using Keras, that was a very simple approach, right? Keras uses a class which is called as sequential, if you remember, right? So initially we created a object of the, a sequential a class, right? And what it does, it creates an empty container for us, right? And then what we can do, we can add a layers into that. So how we can add layer? So using a dense, we can add a number of layers into this. So dense will add a layer. And do you remember, guys, that while we were adding the first hidden layer yesterday, right? Along with this addition of the first hidden layer, it was also adding a input layer for us, right? It was also adding an input layer for us, because while we were adding hidden layer, right, we also gave one parameter that number of features in my data are 11, right? Number of features in my data are 11. And then we added one more dense layer, if you remember. Then we finally added a output layer having one node into this, right? An activation function was sigmoid, if you remember. And then what we did, guys, we compiled our model, right? And in the compilation, what we did, we specified that which optimizer we are going to use. So we used Adam, if you remember, right? That was there. Uh, and those weights were initialized to random. So all these things happen. And then we also specified which loss function we are using. If you remember, we used binary cross entropy for that. And then we also specified that we would be checking the accuracy of our model. So these were the cases, right? And then finally, once our model was ready after the compilation, we fitted the data. And if you remember, guys, what we did in the fit, we specified the train data, features train, and labels train. And then we also specified what is the batch size and what is the number of epochs that we are going to use, guys, right? So this is the case so far, right? So uh, now Vishal is saying so how we know that how many hidden layers are added. As such, there is as such there is no fixed formula, Vishal, to know how many hidden layers can be there in the ANN model. Right? If you increase the number of hidden layers, right, it will affect the complexity of your model. If you have more number of hidden layers in the model, your model is more complex, right? And if your model is more complex, obviously it will affect your processing speed as well, right? So that is there. And that was the case. And if you remember, uh, in yesterday's class, can someone let me know that did we mention sigmoid anywhere in the yesterday's ANN model creation? Guys, did we mention? Yes, we mentioned sigmoid while adding the last layer, last output layer. And at that time, we specified that number of nodes has to be one, and the activation function has to be sigmoid. So Sergeant, please correct yourself, right? So that was there. You can see the video again if you missed that, Sergeant. So that was the case. Yeah, Arushi, you are right. And Dilip, you're right. Satyajit also, Ishika, Akshata, okay, Bharat. So yeah, Santoshini, uh, you're right. Now, what is for today? What we have for today? So, guys, today, we have, we, so yeah, Kavya will try to do that, right? We will try to do that. So now, guys, what is the agenda for today, right? So for today, guys, we are going to focus on a very important area of deep learning, and that is known as, computer vision. That area is known as a computer vision. So what do you mean by computer vision? That automatically, right, our system is capable to identify the images, identify the people or objects in the video or something like that, right? And if you see the example of a computer vision, the example of a computer vision is this: like as soon as you upload your video on the Facebook or upload your image, basically image on the Facebook, right, it starts giving you a prompt that, do you want to tag this friend, do you want to tag this friend, do you want to tag this friend, do you want to tag this friend? This is a perfect example of computer vision, right? The second example are driverless cars, right? Driverless cars. So that is also a example of a computer vision, because you have replaced a driver is no more required into that, right? So although this project is going under heavy testing, and companies like Tesla, companies like Google, and other companies are investing heavy money. They're pumping a lot of money into such kind of projects. And what happens in a driverless cars? There are around 2,000 microcontrollers working at the same time, and it has, right, and it has a lot of cameras, because the cameras help to get capture the images. And once the images are captured, the car takes the decision where to stop, where to take a speed, where the breaker is, what is written on the a signboard, is it a red light, is it a green light. So everything happens that way. So all of these are applications of a computer vision, right? And even you may have seen, guys, that when you are passing through a toll on the highway, right? Do you remember, guys, that when you pass through it, the camera automatically captures the image of your car or a vehicle, and then it identifies the number plate, right? It captures the a number plate data from that image, that what is the uh, a registration number for that vehicle. So that is again a computer vision. So there are so many applications are under computer vision nowadays. A lot of applications are under computer vision. Now question is that how we achieve computer vision, right? So if you are using deep learning to achieve computer vision, the specific architecture that you use for computer vision is called as CNN, guys. This is called as CNN. So yesterday and last 3 days, what we have completed, guys, we have gone through ANN. And mind it, guys, ANN is one of the basic fundamental neural network, artificial neural network, right? And without this, neither CNN can work, and without this, neither RNN can work, right? So this is the basic, a building block of any deep learning project, because now you know that if you use ANN, right, through ANN only you can perform what? A regression and classification, right? Because ANN can be used in both ways, right? It can be used to perform regression as well, and it can be used to perform classification as well, right? So, and all the deep learning projects and all the machine learning projects, and if they are under supervised, a category, either they will perform regression or either they will perform classification, right? And in both of the cases, ultimately, to perform regression or classification, ANN is required. Then what is the role of computer vision? What is the role of CNN? So basically what is happening as an overall, high level overview, if I say that how a computer vision system works, is like this, that, first we will have, so, a CNN, right? So we will put the data from this direction, guys, right? And images will go from this. So CNN will be there, and what is the output of the CNN is, that output will go to ANN finally, right? And then from there you get the prediction, right? So let's say we want to predict whether the image is of a cat and dog, right? Whether the image is of a cat and dog, then data will go to the CNN model first, and whatever the output of the CNN is there, it will go to the ANN, and the ANN will do a classification, and the ANN will do a binary classification. So guys, don't think so that ANN is complete now. ANN is still there. We would be using ANN as well, right? But first, for computer vision purpose, we have to go for CNN. And exactly what the CNN does, basically CNN's role is to extract, right? Its role is to extract the information from image. Guys, what is the role? It will extract the information, it will extract the insight from the image, and that information will go to the ANN, and ANN will make a prediction whether it's a cat or dog. So guys, did you understand this relationship? That what is the use of CNN in computer vision? CNN is used for feature extraction, or extracting the data, extracting the information from the image, extracting the information from the video. That is the role of CNN. Is that clear, guys? Please let me know. Is that clear? And whatever the information it is extracts from the image, right? That would be a passing, that would be going to the ANN, and ANN will finally do, yes, Ishika, you are right. CNN output works as an input data for ANN. You are right. You got it correctly, right? CNN output works as an input data for ANN. And now let's delve deeply into CNN now, that what happens inside a CNN, and how it extracts the information from an image, right? How it extracts the information from a given image, right? So let's understand this part now. After understanding this concept, that where CNN, ANN is being used, now let's discuss the CNN, that what happens in the CNN, right? So CNN stands for Convolutional Neural Network. Convolutional Neural Network. That is there. Okay. Inside a CNN model, or inside a CNN architecture, 4 steps are done. Guys, how many steps we do? We do 4 steps. How we do? The first step that occurs in a CNN is called as convolution. Guys, it's a mathematical operation, right? It is called as convolution. Convolution. So just convolution. So guys, if you are from electronics background, how many guys are from electronics background in this class? Can you please let me know? Just say yes and no, right? Okay. So around, I think a couple of them, replied me in the chat, and a couple of them has, raised the yes button, basically press the yes button. So, yeah, Dhruv, that's good. So, guys, those people who are from electronics background, they know the meaning of convolution. When we try to mix two signals, right? When we try to mix two signals in a particular fashion, that is known as convolution, right? When you try to merge two signals, signals means a stream of information, a stream of data. That is signal only, right? So when you merge multiple signals or two signals, right, that process is known as a convolution, right? That is there. So we'll understand that with respect to what happens in CNN. So convolution as of now is a mathematical process, and what happens in that, we'll understand that later on. Whatever the output we get from the convolution, right? Whatever the output we get from the convolution, we apply a activation function on that, and that activation function that we apply is ReLU, right? So in the second step, we apply the activation function on the output that we have got from convolution, right? And the third step that happens after the ReLU, that step is known as max pooling, guys. That step is known as max pooling. And in the last, right, in the last, guys, the activity that happens is known as flattening. That step is known as flattening. So what exactly is happening, guys? You can see this, that the data, the image will come to the convolution. Then the output of the convolution, right, will be there in the next step, and we will apply ReLU in that. After that, the output will go to max pooling, so we'll apply the max pooling, and then after that, the flattening will happen, right? And the whatever the output comes from this fourth step, guys, it goes to ANN. This goes to ANN. One more thing, guys. One more thing. uh, you know, uh, this convolution ReLU max pooling can happen multiple times. It's not necessary that in a CNN it will only happen once, right? Then what can happen? We can have this like convolution, a ReLU, a max pool, and then again, a convolution, ReLU, a max pool, and then again convolution, ReLU, max pool, and finally, right, a flattening. So you can understand now that flattening will always happen only once. But convolution ReLU max pool can happen multiple times, right? But the flattening will happen only once, because after this, your output will go to which model, guys? It will go to your ANN. So guys, do you understand this pipeline now, that we have a pipeline that first convolution is going to happen, then we are going to apply ReLU on that, then we are going to apply max pool on that. We'll understand what the max pool is, right, what the convolution is, and then finally a flattening of the data. So this is how it happens in the a CNN model, right? So guys, is that clear so far? Is that clear so far with everyone? Okay, yeah. Good. Now, guys, let's take step by step and understand what is happening in the convolution, what is happening in the ReLU, what is happening in the max pooling, and what will happen in the flattening. So let's understand that through a couple of images actually. So let me show you the first step that we do. What are those first step? Okay. Just a minute. Let me open the images. Just hold on. I'm just searching for those images. Oh, so Sylvester sir, have you moved some images out of that folder?
Yeah, so that's in day 4 it is.
Okay, they're in day 4. I was just
Yeah.
surprised where my image is gone. Okay, so so now guys, I got them. So this is my first image that I show you, and here you get it. Can you see, guys? This image is the explanation of a process called convolution, right? And how it is happening, let's understand that. And this is the most critical, part of the CNN. So basically, in this image, what we are showing you, that there is a colored image in the input, and that's why you can see, guys, there are 3 layers shown, right? Why we are showing 3 layers? Because it's a colored image, and every pixel, right, is represented as a set of R, G, or B values. R, G, B, red, green, and blue. Do you remember this, guys? Right? You must have heard that, the images are made of pixels, and every pixel contains 3 elementary colors, right? Red color, blue color, red, green, and blue, RGB, that is called as, right? So, and that's why this image is shown in 3 layers. That these values are representing the R component of every pixel. These values are representing the G component of every pixel. And these values are representing the blue component of every pixel. So if you want to combine everything, so how we will get a single pixel? We will get the first pixel like this. We will combine this with this portion and with this portion, right? So you can see a depth. So this is the 1 pixel. As of now, they are splitted into 3, layers, but this is a one single pixel that we see. Then this is the next pixel, R component, G component, B component. Then the third pixels, right? So this is how you understand about this data. And that's why it is saying that your image has 6 rows, right? Your image has 6 rows, 1, 2, 3, 4, 5, and 6. It has got 6 columns as well, 1, 2, 3, 4, 5, and 6. And what is the depth, guys? Depth is 3, R, G, and B, right? R, G, and B, right? So this is there. So this is a colored image, right? Because in a colored image only you will get a R, G, and B component. Can you guys respond to me, right? So guys, this is 6 into 6 into 3. This is how you represent the image size. How many, what is the height, what is the width, and what is the depth, right? What is the depth that is called as. And that's why, guys, have you remember that when you use a mobile phones, right? When you use mobile phones, they give you that the camera is of that much pixel, the camera is of that much pixels. Any camera takes colored image only, right? Then how it differentiates between different pixels, right? This is 40 pixel camera, this is 100 pixel camera, and this is what, right? So basically, right, basically, that means that means the depth of your image is more if you have a high resolution camera, because to store a pixel, right, are you using 1 byte, are you using 3 byte, are you using 10 bytes, are you using 50 bytes, how many bytes you are using to store, right, store a single pixel, that defines the quality of an image, that defines the quality of image, right? If you have a more bytes to store a single pixel, that means it will have a better quality image, and obviously it will take more space in the memory, no doubt about it. So guys, H, W, and C means like what the height, width, and a depth. height, width, and depth. So 6 into 6 into 3. So that is there. So it is a three-dimensional data that you can thought of, right? So if we say what is the shape of this data, then it would be 6 comma 6 comma 3. Praveen, you are right? So guys, is that clear about uh, about the image representation, that how we have represented an image into three different layers? Why three different layers? Because every pixel is a combination of three: R, G, and P. Guys, give me an answer whether you got it or not. Okay, cool. After this part, guys, after this, let's understand what is happening. Guys, this is our input image, right? Then what we do? Now you can see basically this image has pixels, and pixel has some mathematical numbers basically, right? R, G, and B, they are numbers, right? So now what is happening in the convolution? What happens in the convolution? Basically, we process this input data, right? We process this input data with a filter. What is this filter? Filter is basically a 3 by 3 matrix data, right? A 3 by 3 matrix data. And because this is a colored image, so filter will also have 3 layers, right? So can you see, guys, we have a 3 by 3 matrix data, right? So R component is there, G component is there, and B component is there. Okay. Now what happens in the convolution, guys? We convolute this input data with this filter data. This is the convolution. And how it happens? The red will convolute with the red layer, green layer will convolute with the green layer from filter, and the blue layer from input will convolute with the blue layer in the filter, right? And see what is happening, how it happens. Let's understand this part, guys. Let's focus on this red convolution first, that how it is happening, and finally how we are getting the output, how we are getting the output, how we are getting the result. That result would be the output of your convolution process. So how it is happening, that is very simple to understand actually. See, guys, we have a filter size of 3 by 3. So we create a boundary of 3 by 3 here, right? This is right. And now see what is happening in this red layer, guys. This is the pixel, right? This is the R component, this is the red component. So this value will multiply with this value. So will multiply it with 1. Then 9 will multiply it with 0. Then 2 will multiply with -1. Similarly, 5 will multiply with 1. 6 will multiply with 0. And 2 will multiply with -1. Similarly, 2 multiplied with 1, 4 with 0, and 5 with -1, right? So this is how, and that is shown here. Can you see, guys? Our layer from the input data is getting convoluted with the layer in the red layer in the filter. And similarly, green with the green, and blue with the blue. And what is the final output, right? What is the final output? That would be the summation of this convolution, red layer convolution, then adding with the blue layer convolution, and then finally adding with the so red layer convolution, then adding to the green layer convolution, and then adding to the blue layer convolution. That final output will become the first pixel value in the result, guys. First pixel value in the result. And can you see, guys, this output image, this is also an image actually, but this image has only one layer. That means this image has now become a grayscale image. Grayscale means a black and white image, you can think like that, right? So now there are no more layers. There is only one layer. That means it has become a gray scale image for us. It has become kind of a black and white image for us. So convolution के बाद क्या हुआ, हमारी image one layer में convert हो गई. And why it is giving the 4x4 image only? The depth of this image would be 1 now, guys. Earlier the depth is 3, but now because it has only one layer, that means depth is just 1. So what would be the actual representation for this image, guys? It would be 4x4 into 1. What would be this? It would be 4x4 into 1. That would be the representation of this image. Okay, let's focus a couple of more details on this. Can you see, guys, can someone let me know that why it got output of 4x4, although our input image was of 6x6? If you forget the depth for a now, right? Why it is so? Because that is very simple, guys. As of now, your filter is of 3x3, right? Filter is 3x3. And after this convolution, we get the output here. So 2 is written here. Then what happens, guys, we shift this filter to the right with a 1 location. We shift it to 1 pixel. And if we shift it to 1 pixel, then what would be the, where would the filter would be? Filter will cover this 9, 2, 5, 6, 2, 4, 4, 5, and this some number which is not seen, right? Then convolution will happen, and then we will get the next pixel output here. Then we will shift the filter by 1. So now filter will cover 258, 240, 5, some value, and then 5. And then it will give the output here. Then we will shift the pixel by, then we will shift the filter by 1 pixel. Now it will cover 583, 403, some number here, and then 52. And then it will give the output. So this way you can, give the values in the first row. Then what will happen, guys? Convolution is still there. Then what we do, then we shift this filter, right, down by 1 pixel. So now it will cover which portion, guys? 562, 245, and 565. And now whatever output comes from this convolution, it would be here in the second row. Then we again move on this filter by 1 pixel horizontally. So what is happening, guys? It is a kind of a scanning is happening, if you see, right? We are kind of scanning this using this filter. And let me show you one animation, I think that will create a better impression in your mind, right? See, guys, this is my input image. Can you see? This is my input image on the left hand side, right? And guys, sometimes the filter, right? Sometimes the filter is also called as kernel. Guys, sometimes the filter is also called as kernel. And what we do, guys, we convolute this input image data with the filter. So we will convolute input image with the filter or kernel. Okay. Now what we are doing here, guys, right? What we are doing here, let's say I select some specific values in my filter. Let's say I select the values in my filter. These values are, guys, the first value is 0.625, then the next value is 0.125, and so on. So these are the 3x3 size matrix. This is called our filter, and these are the values. And now, guys, how the convolution is happening with the input image. See this. My filter size is 3x3. So you can see this red, moving, floating, kind of a net is of 3x3. And here the convolution process starts from this location. Can you see, guys? And now here you see that what is the first pixel, guys? What is the first pixel value? That is 206 that you can see there in the middle. What is the next pixel value in the first row? That is 205. What is the next pixel value in the first row? 247. What is the first pixel value in the second row? That is 244. What is the second pixel value, right, in the second row? That is 161. And what is the next pixel value in the second row? 137. What is the first pixel in the third row? That is 192. Right? Second pixel in the third row, 154. Third pixel in the third row, that is 75. And now what I told you, guys, that every pixel value will get multiply, right? Every pixel value will get multiply. So this 4 will multiply with 1, right? 9 will multiplying 0, 2 multiplying with the -1. Same is happening there, guys, right? So same is happening, see this, right? Can you see? And now, guys, whatever the output is coming of this multiplication, the output is coming 178. Can you see, guys? And that 178 is written there on the right side with the, can you see that red square is small square one? That is the output that is being written. So what we are writing here in the right-hand side, we are writing 178 there. Then I move my filter by 1 pixel. That is known as stride. So I'm moving it by 1 pixel. Can you see, guys, now? And then again, the convolution is happening one-on-one, and the output value is 175. And then 175 is written as a second pixel value in the first row in the output image. Then we move it again by 1 pixel. So can you see, guys, the now output is in the third pixel. So we move and scan the complete row this way. Can you see the values of the pixels are changing, but the values of the filter are not changing. Filter values are still same, 0.0, 0.0625, 0 points. So can you see only pixel values are changing, right? See this, right? See, and finally this. And then what happens, guys? I will start from this 1 pixel down, and then can you see that is the first pixel in the second row. And now keep on moving in the right, keep on moving in the right. See. So this is how, this is there, guys. This is there, right? So now, guys, the specific values that I have taken in the filter, they are such values that if I convolute my input image with these values, they will blur my image. Let's say if I take a different selection of the values for my filter, let's say I select different selection, sharpen, right? So now if convolution happens with these values, which values? 0, -1, 0, -1, 5, -1, 0, -1, 0. If I convolute my any input image, then what will happen, guys? They will sharp my output image. These are called filters, guys. And can you now closely relate your day-to-day, magic that happens in your hand, guys? Do you have a mobile phone? And when you take a picture, you apply a lot of filters on that, right? Sometimes you bright something, sometimes you blur something, sometimes you make a colored image to a black and white image, sometimes you do something. That is all result of a convolution process that happens, right? For every filter that you apply, there is a specific data that comes into your kernel. That is a specific data that comes into your filter, guys. Do you get it now, guys? जो रोज फिल्टर तुम अप्लाई करते हो ना, वो फिल्टर बेसिकली इस तरीके से अप्लाई होता है और तब जाके तुम्हारी आउटपुट इमेज में रिजल्ट्स तुमको दिखाई देते हैं. Did you get the idea of a convolution, guys? Right? Okay. Now, Ishika, why we are getting the black and white image? That is very simple, na? Because why? Because your input image is colored. That's fine, right? But now what you are doing, whatever the output of the convolution with the rad layer, right, is coming, we add it here. Then whatever the a convolution result of the green layer is coming, we'll also add that. So finally what we are doing, we are adding everything. And when we are adding everything, then we have just only one value. And if we only have this one value, it will only make just one layer, right? If you write separately that this is my red convolution value, and behind it this is my green a convolution value, and behind it if this is my a blue convolution, then obviously output would be a 3-layered output. That would be a colored image, obviously. But now you are summing everything. That means R, G और B को सब कुछ एक साथ जोड़ दिया. You are not separating it out. Then obviously it has to be a black and white image. Ishika. कहानी समझ में आई guys convolution की, how the convolution is happening. I explained this concept using a black and white image, right? Because colored image में क्या फर्क होता है? Colored image में 3 layer होते, and it would have been difficult for me to show you how the convolution is taking place, right? So, that is there. That is there. Is that clear, everyone? Please respond to me. That is the convolution, that how the convolution is taking place is clear to you guys. Once you understand this, things are easy to understand. Not a big deal, right? Okay. So guys, I have made a request multiple times, right? I have made a request multiple times that when I make a request for a response, please respond, right? Please respond, right? That is there. No, Ravi, I don't have that animation. Right, I don't have that animation. So, okay. Guys, a couple of things before I go to the next topic. If you are taking a filter to sharpen the image, you have these fixed values. If you are taking a filter to blur your input image, you have these fixed values, right? If you want to give an embossing effect to your image, then you have these fixed values. So these are a couple of filters that are predefined, right? These are predefined. These are the predefined, right? So these are the predefined kernels, predefined filters, right? No, Himanshu, not possible, right? There are other ways for that. So that is there. Now, after the convolution process, what was the next step that I told you guys? What was the next step I told you? After the convolution, what will happen in the CNN? ReLU will happen, right? ReLU will happen. And see guys, now listen to me. I'm still on this data, right? I'm still here on this. And let me, take this. Guys, if I'm doing a convolution, right, of input image with my kernel, which is a kernel for sharpening the image, can you see that at some of the places the output is in minus, right? Can you see? Here the output is minus 212. Can you see? Minus 212. That means the pixel value is a negative in the answer. The pixel value is a negative, right? But a pixel value cannot be negative actually, right? Either it can be 0 or either it can be more than 0. How come a pixel would be, a less than 0? So what we do after convolution, if in the convolution process, some of the pixels got negative values, then what we do? We apply ReLU. And what happens in the ReLU, guys? Do you remember that if certain value is less than 0, what will it become, guys, after applying the ReLU? If a certain value is less than 0, what happens in the ReLU? If the value is negative, it becomes 0 in the ReLU, right? If the value is positive, it remains as it is, right? If the value is positive, it remains as it is. But if the value is negative, and that's why, guys, wherever this image has negative pixel values, they all will become 0 actually after the ReLU is applied. After the ReLU is applied. So that is the next step, guys, right? What happens? We do this, apply the ReLU on that. That will put our negative pixels to a 0 value. So we have completed 2 steps now, guys. We started with the convolution. After the convolution, we got some of the pixel values as negative pixels. And after applying the ReLU, they all became 0. Not every pixel became 0, right? Only those pixels became 0 which had a negative value, right? In the third step, guys, can someone let me know what was the third step I told you, guys? What is the third step I told you? Max pooling, right? What happens in the max pooling? That is a very interesting, process. Can you see our image there, guys? Can you see the image? Here, guys, let's say you have applied a convolution. Let's say you have applied a ReLU as well. And after the ReLU, you have got an image which has these pixel values. So guys, this left hand side matrix that I show you is the output after the ReLU. The convolution has been applied, ReLU has been applied, and that's why you can see some of the pixels are 0 here. Now guys, can you see this image is of a 4x4 now, for example, right? It is just for a explanation purpose. So input image is 4x4. And what happens in the max pooling then, right? What happens in the max pooling? See this. What happens in the max pooling? In max pooling, guys, we take a window of 2x2. You take a window of 2x2. So we'll take a window of 2x2 that you can see. In that 2x2 window, we pick only the pixel which has the highest value. So can you see, guys, in this 2x2 window, what is happening? There is a pixel value 12, there is a pixel value 20, there is a pixel value 8 and pixel value 12. So what is the maximum pixel value, guys? 20, right? So we give 20 in the output. Then we move that 2x2 window by 2 pixels. So now the window would be here. In this zone also, we will pick the maximum pixel, guys. So can you see, we get the 30 here, right? And then we move down by 2 pixels. So now we are here. So our 2x2 window is here, guys. In this region, what is the maximum pixel? 112. So we pick the 112 only, right? And then finally our window is here. Again, 2x2 area, we'll pick the maximum pixel value, that is 37. This process is known as max pooling, guys. This process is known as max pooling. And now you can sense what is happening in the max pooling. In the max pooling, guys, we are only retaining the highest pixel value, and highest pixel value indicates the most important feature in the image. That means it is a kind of a activity of feature extraction, right? It's a kind of a activity. That means those features which are not very highlighted in the image, we are going to drop them. And only we continue with those features, right, which are sharp in the image, right? Which are, right, जैसे होता ना कोई image है, उस image में, have you seen those kind of games on the TV where they show you the only eyes of a particular star, and then they ask you to can you guess the star, who is the star, right? Although you have not seen the entire face, but by just looking at a particular feature, right, that how the eyes are they sharp, are they that, are that, you identify which star it is. That is all happening in the CNN as well, right? They don't look at the features which are not very important, which are not very helpful in identifying something, that who is in the image, right? So they only continue with those features, and a sharp feature will always be indicated as a higher value of the pixel, guys, right? And that's why from this zone 2x2 zone we are only picking 20, and in this zone of 2x2 we are picking 30. That means हम हर चीज को छोड़ देंगे, will only continue with the features which are really important to us. And this is a feature extraction process. And now can you see, guys, in the feature extraction, our size of the image is also reducing. Can you see? Input image is a 4x4, right? And then we are getting output as 2x2 only. So यहाँ पे size कम हो गया है. इसको कहते हैं feature extraction, size reduce हो गया है, right? Sometimes guys, in a CNN, right, people do not follow max pooling approach. they take another approach. That another approach is known as average pooling, right? Most of the time, in 99% cases, people go with max pooling only, but sometimes people go with average pooling also. And what is the average pooling actually? Now you can understand that they are not throwing any pixel. They are calculating the average of all these four values and then giving the output. Again, calculating the average of these 4 pixels and giving the output. Calculating the average of these 4 pixels and giving the output. And so this way, what happened? In this way, we are not dropping any particular feature. हम हर feature को count करते जा रहे हैं, right? That is there. So, this is there. So guys, generally we do not go with average pooling. Average pooling में तो ये है कि आपने थोड़ा थोड़ा सब कुछ इकट्ठा कर लिया है, राइट? ये भी ले लो, ये भी ले लो, ये भी ले लो, किसी को छोड़ो मत, किसी को पूरा भी नहीं लिया और किसी को छोड़ा भी नहीं. That is happening in this average pooling actually, right? So most of the time people go with max pooling, but average pooling is also possible in deep learning. So sometimes it may be a requirement in terms of a project that people may go for average pooling as well. But what, like, the kind of projects I have seen or I have worked, they were all involving max pooling only. So guys, is max pooling clear to you? Yeah, Ishika, both may give different results, obviously. So guys, is that clear? Please respond. Cool. After this step, what was the last step, guys? After that, what was the last step we had? Flattening. Flattening, right? Not Niranjan. ANN is will come, but after the 4th step. And the 4th step was flattening, guys. What is the meaning of flattening? The flattening is very much related to reshaping. Do you remember reshaping in NumPy? Converting your 2-dimensional data to 1 dimension or 1-dimensional data to 2-dimensional and all that. Flattening means, guys, reshaping. That means after the max pooling, your output image is of 2 dimension. Can you see, guys? After the max pooling, your image, right? Image is of a 2 dimension, right? So let me show this here. I will explain this now. So here you see, guys, we had an input image here. We had an input image. Obviously, it has 3 layers, right? It has 3. So R, G, and B, right? So R, G, and B. Here we perform a convolution with the filter. What is the size of the filter, guys? 3 by 3. The size of the filter can vary. People take most of the time 3 by 3, but it can happen 5 by 5 as well. It can happen 7 by 7 as well. That depends, right? So most of the time we take 3 by 3. Now convolution happening, and now you see, guys, we have an image 4 by 4, for example, right? 4 by 4 images there, right? 4 by 4 images there. Now, guys, on this we apply ReLU, right? So the only thing that changes here, the size will not change in the ReLU, right? Size is still that 4 by 4, right? The only change that will happen is that any negative pixel will become 0. That's it. And now, guys, what we do after this, we do max pool, right? So in the max pool, if the max pool window is 2 by 2, what will happen in that case, guys? We get a input image of 2 by 2, right? We get an input image of 2 by 2. Now, guys, this image will work as an input for us, right? Input for us for what? That this has to be, a feed to our ANN model now. ये image जो यहाँ output में मिल रही है after max pooling, it has to be, fed. It has to be, fed to the ANN model. But how we can feed it? Can someone let me know if this image size of 2 by 2, how many nodes we will require in the input layer, guys? How many nodes we will require in the input layer? 4 nodes. Now you know that, right? Okay, how come we need 4 nodes? That is very simple, actually, right? See this. you know, uh, see this Dhruv, I have, this earlier, can you see the output of this image is 4 by 4. Then we applied ReLU, so still the image is of 4 by 4, and then we applied max pooling of the 2 by 2, and that's why the size has reduced, right? And now the size is only 2 by 2. Why? Because out of these 4 pixels we wrote this value, out of these 4 pixels we wrote this value, out of these 4 pixels we wrote this value, and out of these 4 pixels we wrote this value. So 2 by 2. Now guys, what happens? We have to reshape this data. As of now this is 2-dimensional. So how do we reshape, guys? Let's say this pixel is 20, this pixel is 15, this pixel is 100, and this pixel is 90, for example. So what we do, guys, we flat this 2 by 2 image. Flat means we reshape it from 2-dimensional to 1-dimensional, guys. We reshape it to 2-dimensional to 1-dimensional. So what will happen, guys? It will be converted into 1 dimension. So this first value will be 20, the next value would be 15, the third value would be 100, and this would be 90, right? So this is there. And now you can see, guys, this data, right? This data will go to the first node in the ALN layer. This data will go to the second node in the ALN layer, that is input layer, right? And this data will go to the third node, and this feature, right? Because now they will work as a feature for ANN, right? They will work for as a feature for the ANN, right? And this will read by the, so if you have, if the length of this, 1-dimensional array, why we are calling 1-dimensional array? Because that has been flattened. It has been converted from 2D to 1D. So what is the length? Actually, you have to have so many nodes in the input layer, right? So then this would be Shruti Chaudhary, you take max pool as 2 by 2 or 4 by 4 only, and not in the odd selection process, right? Yeah. So this is, this is there, guys. Is that this process clear to you now? I have explained all the 4 steps, that how we had an input image that was a colored image, then how we got convoluted it, then how we got the output, then how we applied ReLU on it, right? So that is Pratik, I will talk about that tomorrow. You have a right question, but I will answer that tomorrow, right? So this is, yeah, Nitin, you can see this now, that this image, right, after the max pooling is this, and now we are flattening it to 1-dimensional. So how many pixels it has? 4 pixels, right? And that's why we are getting the 4 nodes in the input layer, right? So only what we get after the max pool, only this data will go to the ANN. And this is because we have extracted the features, right? So these are the extracted features, and we'll use them in the ANN model to, classify whether it's a cat or whether it's a dog, right? So this is there. So, Shreyans Gupta, yeah. So, Shreyans, can you do Google that? Can you Google that? That would be easy for you, right? So maybe you can use some mean squared error or something like that, right? नहीं नितिन, ये इनपुट लेयर से सिर्फ डेटा रीड किया है. अब जो नेक्स्ट हिडन लेयर बनेगी, लेट से उसमें 3 नोड है नितिन, तो ऐसा होगा ना कि इसका आउटपुट यहाँ पे भी जा रहा है, यहाँ पे भी जा रहा है, इसका यहाँ पे भी जा रहा है, यहाँ पे भी जा रहा है, यहाँ पे, इसका यहाँ पे, यहाँ पे, यहाँ पे, राइट, इसका यहाँ पे, यहाँ पे, यहाँ पे. ये बात की बात है. इनपुट लेयर से तो डेटा ऐसे ही रीड किया जाएगा जैसा मैंने बताया है, राइट? सो दिस इज देयर. So guys, is the CNN process clear to you? And so that now we can move on to some practical and see how a CNN can be, used in Keras, right? How CNN can be used in Keras. So see now, I'm moving to a Keras. I'm moving to, this a collab now. So guys, what is happening? Uh, Today, we create a deep learning model, right? Today, we create a deep learning model. And in that model, what we want to do, in that model, we want to predict uh, uh, that what is the number written in the image. कि इमेज में क्या नंबर लिखा हुआ है, 1 लिखा हुआ है, 2 लिखा हुआ है, 0 लिखा हुआ है, 3 4 5 6 7 8 एंड अप टू 9. सो 0 से लेकर के 9 तक कुछ डिजिट्स लिखी हुई हैं इमेज के अंदर, राइट? एंड वी हैव टू predict that what the number is there in the image, in the input image, guys, right? In the input. Do you get the problem statement, guys? We have couple of handwritten images, right, guys? We have couple of handwritten images, and we have to identify that what number is written in the image. From where to get this kind of data? This kind of data is already available on the internet, guys, and this kind of data is known as MNIST dataset. So let's look for MNIST dataset. MNIST dataset. See this. Here we get it. MNIST data. So in this case, guys, yes, Isika, you are right. In this case, no CSV file would be used. Why CSV file can be used here? The data is an image, na? So there is no CSV file in that case, right? So I'm just searching for MNIST data. क्या हुआ भाई? So just a minute. So here we go. Okay. MNIST data. Okay. Can you see, guys? MNIST database Wikipedia. So let's see. Rohit, let's see what is happening. This is MNIST database, guys. What is the MNIST database? Can you see? We have lot many images, and these are the handwritten images, guys, right? So someone writes 0 this way, someone writes 0 like this, someone writes 0 like this. So we have different collection, right? Someone writes 1 this way, someone writes 1 this way, someone writes 1 this way, someone writes 2 this way. So we have a lot of data. So these are the images, guys. The images are black and white, and each image is of size 28 by 28. Guys, each image is of size 28 by 28. How many images these are? How many images these are? These are in total, guys, 70,000 images. 60,000 images are already there for you for training purpose, and 10,000 images are for testing. That means it has already done a train test split for you. It has already given you that this is your training data and this is your test data. So how many records in the training set, guys? We have 60,000 images. So these are the images, right? These are the images, and every image has a label as well. right? Otherwise we cannot train the model. We have to use labels as well, right? हमें बताना पड़ेगा कि भाई ये इमेज जीरो की है, ये इमेज भी जीरो की है, ये इमेज भी जीरो की है. So we have to have the labels as well, right? ये तो इमेज में लिखा हुआ है. We need to tell our model that this is, actually zero. We need to tell, during the training that this is actually zero. Image में लिखा हुआ है, लेकिन बताना पड़ेगा कि what is the label, right? So this is a labeled data, guys, right? And we will use this data. So from where we can get this data? In the Keras, we already have this data set. In the Keras, guys, we already have this data set. So can you see? I'm importing the Keras. So I'm importing the Keras, right? We got the Keras imported. Guys, do we need to mount our Google Drive in this example? What do you say? Do we need to mount our Google Drive? No, we don't need to mount our Google Drive. Why? Because we are not loading, right? We are not loading any data from Drive. This data set is already available in the Keras, so we will use that data set, right? So can you see, guys, what I'm doing? Here you can see that I'm importing MNIST dataset. Can you see from keras.datasets import MNIST and couple of other functions as well, but I'll talk about that function later on. And now, guys, I'm calling a method called MNIST.loadData. So let me increase the font a little bit. I think that would be better for you. Is that okay now? Yeah. Can you see now? Right? MNIST.loadData. When we load this data, right, it will download the data from a location, right, and will give us what? Train images, train labels, test images, test labels. So the image data would be in this for training purpose, image data would be in this for testing purpose. The corresponding to this training image data, we have the label in this, right? And corresponding to this test images data, we have the label in this. So let's do this, guys. I will explain more details after this. So we have got the data, guys. Now let's first see that what are the number of images for training. So how we can check this, guys? Train underscore images dot shape. So it will let us know. It is telling that you have got 60,000 images and every image is of 20 by 28, right? This is this, right? So we got 60,000 images and every image is of what size, guys? 28 by 28. And these are the black and white images, all, okay? If we want to know the shape of a specific image, all images are of 28 by 28. So I can go for a specific image, guys. Can you see? Let's say I want to see that what is there in this image, which is at 0. Can you see? Train images, right? Train images, and then I'm specifying the index. Can you see? Can you see, guys? This is the first image of 28 by 28. How come I know that it is an image of 20 by 28? So it will have 28 rows and 28 columns. Can you see this? This is my first row. Can you see, guys? This is my first row. So from here to here, this is my first row. And here there are 28 entries in this row. That means it has got 28 columns. 0, 1, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So 28. This is the second row. This is the third row data. This is the fourth row data. That means this image is already converted into ND array, right? This is the ND array format of the image, guys. This is there. And now can you see, earlier we were all getting the, a 0 pixel data, but now we have got some non-zero pixel values as well. Can you see? Some values are 18, some values are 255, and someone and like. So this is your one, image data, guys. And if we want to know what is the shape of this image, one image I'm talking about, and see this, 28 by 10. And now if I want to know that what is the label of this image, so data is lying train underscore image. Where the label is lying, guys, मैं कैसे पता करूं कि image कौन सी digit की है? कैसे पता करूं? राइट तो उसके लिए मुझे क्या करना पड़ेगा, आई विल हैव टू गो टू ट्रेन लेबल्स, राइट. So I will have to go to train labels. So see this, right, train labels. And पूछूंगा कि बताओ यार जीरोथ इमेज जो है, राइट, वो किस डिजिट की है. सो नाउ इट विल टेल मी गाइस कि भैया वो जो इमेज है वो 5 की है. that image is of digit 5. I can check with other as well, right? Let's say I want to check that what is the image which is at index 11 out of 60,000. मैं 11th index वाली image को check कर रहा हूँ. And then here you can see the data, guys. A lot of data is there, 28 by 28. इस इंडेक्स पे जो इमेज पड़ी है उसका लेबल क्या है, हाउ टू चेक गाइस, train underscore labels, right? And here as well it says 5. Okay, can I do something else? Maybe I can check for some other. So let's say I want to check कि जो 5 पे है उसका क्या लेबल है, 2, right? And that data would be different as well, right? So उसका data क्या है वो भी हम यहाँ पे देख सकते हैं. So this is the data we have, guys. Can you see? This is the data we have, right? So this way, guys, can you relate now? Can you guys now get a clarity in your mind that what we have? Actually, guys, we have got this data. So now this is the training data. So that means it has images, and images are all stored in what format, guys? ND array format. वो images already ND array में convert की हुई हैं, और उन images का क्या label है वो यहाँ पे दे हुआ है. फिर टेस्टिंग के लिए भी हमें images दी हुई हैं, और उन टेस्टिंग का क्या लेबल है वो भी हमें यहाँ पे दिया हुआ है. दिस इज 60,000 and this is 10,000. Is that clear now, guys, about what is the MNIST data set? What is the MNIST data set we have, right? Okay, yeah, cool. Now, guys, as a first activity, right? As a first activity, right? The next step that we have to do, guys, as of now, if you see, when we are saying that give me the shape, what it says that 60,000 images are there and 28 by 20 is the size. That means 28 rows and 28 width. Row और width तो दी हुई है. क्या इस हर image की depth भी दी हुई है? Is the depth given to us, guys? No, depth is not given to us, right? And what should be the depth in any way, guys? Because these are the black and white images, right? The depth would be 1, right? So guys, we need to reshape our images. And how to reshape, guys? We need to tell that images are 60,000, and now each image is of 28 by 28 by 1. That reshaping we have to do, right? Otherwise training will not happen, right? So guys, we reshape our data too. So we reshaped it. Now, after the reshaping, guys, the next step that we have to do, for that purpose, let me tell you guys. Can you see? After the reshaping, I just want to check that what is the data in the image which is at index 0 out of 60,000. 0th row, 0th index पे क्या image है वो ये है, right? The first row completes here, second row completes here, and so on, right? ये बहुत सारा data यहाँ पे है. And now can you see, guys, मैंने कल आपको बोला था, I told you yesterday that every feature, right? Every pixel, in fact, every pixel in the image works as a feature for us. Do you know that? Every pixel in the image works as a feature for us, right? So what we want to do here, we want to do feature scale here. हमें यहाँ पे feature scale करना पड़ेगा, क्योंकि कुछ values तो 0 हैं और कुछ values 255 तक भी जा रही हैं. उन सबको बराबर रेंज में लाने के लिए, उन सभी वैल्यूज को, to bring all the values in the same range, what we do, we have to do feature scaling. Guys, do you remember yesterday we got a concept of feature scaling where we applied a standard scaling and converted all of the values so that they became in the same range? They came, they fell into same range. Guys, do you remember that feature scaling concept was discussed yesterday? So we have to perform the feature scaling here as well, right? We have to perform feature scaling here as well, guys. So I'm going to perform feature scaling. How to perform feature scaling, guys? This time we will perform min max scaling. Yesterday we were performing standard scaling, right? Today we will perform min max scaling. So let me explain what the min max scaling is, right? So let me explain what the min max scaling is. So guys, let's see how the min max scaling works. So let's say we have a one column. One value is 0, other value is 8, someone is 10, somewhere is 2, something is 5. See this, guys. In min max scaling, guys, what we do, we apply this formula: x minus minimum value divided by maximum minus minimum, that is range. So can you see, guys, in this column, what is the minimum value? Minimum value is 0. What is the maximum value? That is 10, right? And now we want to feature scale. So what will happen to every value? 0 minus minimum value, that is 0, divided by max minus minimum, that is 10. So 0 by 10, right? So that is there. Prashant, we are reshaping the data because we have to specify the depth as well. And earlier जब हमने download किया तो उसमें depth का section नहीं था, and that's why we had to reshape it. Just उसमें depth add की है, रो और कॉलम का काउंट चेंज नहीं किया है, वो अभी भी 28 by 28 है, सिर्फ ये बता दिया कि डेप्थ इज 1. दैट्स इट. प्रशांत, राइट? दैट इज देयर. So now, guys, we are performing this min max scaling, right? Min max scaling, 8 minus 0 divided by 10, 10 minus 0 by 10, 2 minus 0 by 10, and 5 minus 0 by 10. So every value is used, and we are performing min max scaling. And now, guys, let me know that if we want to perform min max scaling here, right? We want to perform min max scaling here. Let me show you the data, right? Can you see, guys? Can let you know, guys, that out of these pixels, what is the minimum value and what is the maximum value, guys? What is the minimum value and what is the maximum value? So maximum value will go up to 255 and minimum value will go up to 0. So minimum is 0 and maximum is 255, guys, right? And if we perform min max scaling, so that means ultimately you are dividing every value by 255 only, right? You are dividing every value by 255. Why dividing 2? Because if you do the minus with minimum, but here the minimum is 0 already, so you don't need to perform any a subtraction, and you can directly divide by 255 because max is 255, minimum is 0. So here you are directly dividing every pixel value by a 255, guys. So can you see, guys, as of now here you see 0 or something like that, but after performing this feature scaling, can you see this, that this time we have the values like this? See, values are here we see, here we see. Can you see now the values, right, which were like 255 or 180 or 150 or 15, so now they are converted in a lower range, right? So this is this. Yeah, Kavya, we can do that. We can do that. Min max is also there in the Keras, and we can apply that, right? So this is the pre-processing part, guys. In the last activity of the pre-processing, guys, what we are doing, do you think, guys, that what is into the train labels? If I print this data train labels, ये बता रहा है कि पहली जो इमेज है वो 5 की है, सेकंड इमेज 0 की है, थर्ड इमेज 4 की है, and so on, right? So on. So guys, let me show you let me show you here. Everybody please focus what we are talking about. हमारे पास you know data है. This is the data, this is the data train labels, right? So हमें हर image का label मिला हुआ है. हर इमेज का लेबल कैसे मिला हुआ है वो बता रहे हैं कि वो इमेज 5 की है या 0 की है या 4 की है. सो गाइज लाइक समथिंग लाइक 5, 0, 4, कोई इमेज 1 होगी, कोई इमेज 2 होगी, कोई 3 होगी, कोई 7 होगी, कोई 8 होगी, कोई 9 होगी, राइट लाइक दैट. Is any other number left, guys? 0 is there, 1 there, 2, 3. Okay, 4 is also 5. 6 is not there, so we got the 6. So these would be the values in the labels, guys, right? These would be the labels. How many unique values we have, guys? How many unique values we can have in the label data? Do you have any answer to this? How many unique values we can have in the label? Yes, you guys are right. It will have 10 unique values. Out of 60,000, या तो कोई इमेज 0 है या 1 है या 2 है या 3 है, 4 है, 5 है, 6 है, 7 है, 8 है, 9 है, या बस तो 10 different. So अगर if we want to, guys, if we want to convert this data to a one hot encoded representation, तो हमें कितने नए कॉलम की जरूरत पड़ेगी? We will need 10 columns, right? 10 unique values are there, right? 0 से लेकर के 9 कितनी values होती हैं? 10. So how many new columns we will need, guys? One column for 0, right? One column for 1, one for 2, one for 3, one for 4, one for 5, one for 6, one for 7, one for 8, one for 9, and one for, okay, that's it. And guys, if the first image is 5, right? If the first image is 5, how I can represent this in one hot encoded? If the first image is 5, I have to make this to 1 and rest of the values to what, guys? Rest of the values to 0. See this, right? So this represents this is the kind of Himanshu Rajput unique values. तो 10 होंगी ना. 0 एक unique value है, 1 है, 2 है, 3 है, 4 है, 5, 6. This is there. That is there. So 10 hai. There are 10 unique values, right? So Kavya is saying, sir, why one hot encoding? These are number data. You are right, Kavya. Basically, what we want to do, basically, this is not a number data. First of all, guys, this is representing a kind of a class. That 5 is representing a class, right? All these are basically unique categories. They are unique classes, right? Someone representing 0, someone representing 1. So these are not numbers as such, they are representing the category, right? They are representing the category, and that's why we have to convert this kind of a label into a one hot encoded representation. Kavya, is that so? This इसको ऐसे मत समझो कि 5 0 बेसिकली ये एक क्लास को शो कर रहे हैं. They represent a class, right? And when we do this, guys, when we do this, we have a method in Keras that will convert our data already. We don't have to do this. We can directly call this method two categorical. Can you see? Two categorical, right? So it will directly convert our data into that format. And now can you see, guys, if I convert my after this, if I print my train labels, you will see this. Can you see? Earlier what we were getting 5 only, right? But what we are getting instead of 5, we are getting this much of data. Earlier we were getting 0 only. Now what we are getting, can you see? This is the representation. Earlier we were getting 4 only. Can you see? We are getting this representation. So now we have converted our data from that format to a one hot encoded format. After this part, guys, right? After this part, we are done for today's pre-processing part, and now we can directly go to our Keras model. Now we can, okay, अब क्या करें? अब तो बहुत आसान है, right? Modeling तो बहुत आसान है. Now we know क्या करते हैं सबसे पहले, guys. What we do while building a model? First, we create a sequential model which is empty container. Do you remember from yesterday? So, guys, we are doing a empty, a container we are creating, right? Yeah, Akshita, we are not doing that today, right? We are not doing that today. So Akshita is saying, sir, yes, sir, sir, yesterday we eliminated one column, but today I'm not doing that. I'm just directly, going with that only. So see that, right? So we have this. So guys, after this, after the model has been created, right? Guys, we are creating now listen, guys, what is happening. We have created a sequential model, and I told you guys what will happen now. First, we have to go for CNN, and then we will add ANN, right? So first, guys, first we have to add convolution layer, then we have to add ReLU, then we have to add max pooling, and then we have to perform a flattening. But convolution ReLU max pool can happen multiple times, one after another, and flattening would be the last one. So see this, guys, what is happening here. Can you see on the line number 4 I added my sequential model. In the line number 5, can you see, guys, I'm adding a convolution layer. In the convolution layer, I'm adding 32 nodes, and the filter size that we want to apply is 3 by 3. And within this line, I have said that please apply ReLU, right? Please apply ReLU. So I will not, go for a ReLU layer separately. मैंने दोनों को यहीं पे combine कर दिया है, right? And do you know, guys, that when we add our first layer this way, we always need to tell that what is the input size of my data. Guys, can you justify that why I have written input shape is equal to 28 by 28 by 1? Why I have done that? Why I have written 28 by 28 by 1? Why not something else? Why not 50 by 50? Will 50 by 50 work here, guys? Will the 50 by 50 by 1 work here? No, it will not work here. Why? Because we have to specify that what is the size of my input image. And currently my input image is 28 by 28 by 1. 1 is the depth. This 32 is that how many, nodes you have in the convolution layer. So what is the meaning of this? Let me explain that part to you guys. अभी हमने convolution ReLU max pool को समझा. So what is happening now? Listen everybody, very important. ये ज्ञान जो मिल रहा है उसको ढंग से पकड़ लो, बाद में हाथ नहीं आएगा. See this, guys, this is my convolution, right? 2-dimensional convolution 2D. Because why we are doing convolution? Because it's a 2-dimensional data. So conv 2D. We have, a 32 nodes. So 32 here, 32 here, 32 here, and so on. So these are the 32 nodes here. What is happening on the each node, guys? What is happening in the each node? We have this image, right? We have this image. This image will go to this node. This node has now 3 by 3 ka matrix. So this node has a 1 matrix of 3 by 3. So convolution will happen with this. This image data will go to this node as well. This node also has a kernel or a filter of 3 by 3 as well. So every node has a filter of 3 by 3. And initially all these values are randomly initialized. All these values are randomly initialized, right? No fixed value. Random values are initialized into, you can take 5 by 5 as well, no doubt about it, right? You can take 5 by 5 as well. So that means on this input image, we are applying 32 filters. We are applying 32 kernel operations. Did you get, Sajan, now? Right? And every, output of this, this convolution will move to the next level now, right? So you can have, you can have 16 as well. There is no, guys, this number is not fixed. You can have, a 16 as well. You can have, 32 as well. You can have 64. So साजन इसको ऐसे समझो कि हर नोड के पास एक फिल्टर लगा हुआ है, राइट? जितने ज्यादा फिल्टर लगाओगे उतना ही एक्सट्रैक्शन अच्छा होगा. More the number of filters you have, better is the extraction of the data from the image, right? And so that means we are applying 32 filters. So you can, when I say 32 node, that means you are applying 32 filters. And what is the size of each filter? That is 3 by 3, right? That is 3 by 3. Is that clear now, Sarjan? Yes, Sarjan, you can use 64 as well. You can, right? And even you can change the size of filter. Okay. So guys, after this convolution and ReLU, can you see, guys, I'm going for a next layer, and what I'm doing in the next layer, I'm applying max pooling. Guys, I have not written activation ReLU as a separate layer, guys, because मैंने यहीं पे specify कर दिया, यहीं पे. So I have combined the first two steps. Then max pooling. What is the window size for max pooling, guys? Can you see? 2 by 2. The output of this max pooling, right? No, Praveen, not, right? So output of this max pooling, right, again goes to a next convolution layer, guys. Can you see? Again, we have a convolution. This time we have 16 nodes. We have 16 filter, and this time I have made the filter size to 5 by 5. And can you see, guys, this time we are applying activation ReLU, right? Yeah, Praveen, it's a 2D filter, right? And guys, after that, I'm applying max pooling again. So this is the, case. So this creates my model, और अब मैं तुमको दिखाता हूँ कि मॉडल में क्या क्या छुपा हुआ है. So let's see the model summary. Can you see, guys? Right? ये कह रहा है कि जो तुम्हारी फर्स्ट कॉन्वोल्यूशन लेयर है, राइट, जो फर्स्ट कॉन्वोल्यूशन लेयर है उसका आउटपुट जो है वो 20 by 26 का होगा. मतलब इनपुट इमेज तो कौन सी थी? 28 by 28 की, बट आफ्टर अप्लाइंग द कॉन्वोल्यूशन वो इमेज का साइज क्या हो गया? 26 by 26 हो गया, राइट? आफ्टर अप्लाइंग द मैक्स पूलिंग उस इमेज का साइज क्या हो गया? 13 by 13 हो गया. वो तो होना ही था, हाफ होना था ना, 2 by 2 का विंडो ले रहे हैं हम. उसके बाद फिर से कॉन्वोल्यूशन अप्लाई हो रहा है, उसके बाद वो इमेज किस साइज की हो गई? 9 by 9 की हो गई. और फिर उसके बाद हमने फिर से मैक्स पूल अप्लाई किया है, तो फिर इमेज कितने की हो गई? 4 by 4 की. So can you see, guys? Reduction in the size is happening here. Is that clear now, guys? Sajan? या इसी का that is also possible. आप चाहो तो कॉन्वोल्यूशन और मैक्स पूल एक ही बार करो. अब समझ लो इस चीज को कि हम बार बार मैक्स पूल और बार बार कॉन्वोल्यूशन मैक्स पूल क्यों कर रहे हैं. व्हाई वी आर डूइंग अ कॉन्वोल्यूशन मैक्स पूलिंग अगेन एंड अगेन. एक चीज बताओ, गन्ने की मशीन पर रस आपकी ग्लास में आने से पहले वो गन्ना कितनी बार उस मशीन से निकलता है? सो ग्लास में रस का आना इमेज का फ्लैट होना है. ग्लास में रस का आना इमेज का फ्लैट होना है, जिसको आप पी सकते हो. उससे पहले, राइट, वो गन्ने वाला उस गन्ने को बार बार उसमें मशीन में डालता है, और तब तक डालता रहेगा जब तक उसमें से रस निकलता रहेगा, राइट? And that's why we are doing multiple convolutions and max pooling convolutions and max pooling, so that we get maximum information extracted from that input image. Yes, Pratik, you will lose the data. Obviously, you are losing information, right? Max pooling में क्या होता है, right? What happens in max pooling? Out of 4 pixels, you only pick the highest pixel value, right? So that means you are losing rest 3, you are losing rest 3 pixels, and that is the loss of the data. Pratik, do you agree now? कि 4 में से सिर्फ एक ही को तो पिक कर रहे हो, बाकी को तो छोड़ रहे हो. That means it's a loss of the data, right? So that is there. Yeah, Pratik, but what we are doing, we are keeping the feature which is most important, right? The feature which has the highest pixel value is retained, right? So accuracy is still with us. जो important नहीं है उसको छोड़ रहे हैं, जो important है उसको तो continue कर रहे हैं. Pratik, right? Now guys, after this, उसके बाद क्या करते हैं? After the ReLU and max pool, what should we do, guys? We should flatten the data, right? Now we are flattening the data here. And after the flatten has happened, उसके बाद data कहाँ जाना चाहिए? Where it should go, guys? It should go to which model? ANN, right? So now the next 2 lines, we are creating a ANN model. Can you see? We are adding a dense layer now. अभी तक dense layer add नहीं किया था, right? अभी तक कौन से layer? Convolution max pooling, and then flatten. And now we are adding the first layer for our ANN. And this, we are taking 64 nodes, we are applying ReLU, right? So that means it is the hidden layer, first hidden layer, right? और क्योंकि input पीछे से आ ही रहा है, तो we don't have to specify the input size. वहां से जो number of pixels आएंगे उसके हिसाब से it will create an input layer for you, right? And then finally, guys, can you tell me how many nodes we should have in the output layer? This is the output layer, guys. How many nodes we should have? कितनी यूनिक कैटेगरीज हैं हमारे लेबल में? हाउ मेनी यूनिक कैटेगरीज वी हैव? या तो इमेज 0 होगी, या 1 होगी, 2 होगी, 3 होगी, 4 5 6 7 8 9. इसका मतलब we have 10 classes. And if we have the 10 classes, how many nodes we should have, guys? That should be equal to number of classes, and that's why we are getting. And what activation function we should have, guys? It's a multi-class classification, or it's a binary classification, guys? Is it multi-class or binary? It's a multi-class. So which activation function is required in this case, guys? Softmax is required, right? Yeah, Vipul sir, thank you. And now, guys, after that, we are going to compile our model, right? You can change that, Kavya, not a fixed number. You can make it 32, you can make it 80. You can change, you can. So guys, क्या करना है, right? Manashwani, it's not a fixed data, right? You can change that, right? You can change that. So guys, क्या करना है? After the class, you have to play around with this code. Try to change the values, try to change the parameters, try to add one more hidden layer, try to add one more, a convolution, right? So that you understand the things well, right? So this is, आपको भी ये वो गन्ने की तरह बार बार इसको देखना पड़ेगा, तब जाकर के you will get a 100% accuracy in terms of understanding, right? अभी कितना चल रहा है? 60-70 पे चल रहा है हमारा, right? So this is the case. 64 are the number of nodes in the hidden layer, Santoshni. 64 are the number of, nodes in the hidden layer. And you can change that. It's not fixed, right? Now, guys, we are going to compile our model. So how to compile? We are going to specify the optimizer. This time we are not using Adam. We are using RMS prop, root mean square, We are specifying the loss function. This time we are not calling binary cross entropy because this is a multi-classification. So we are calling categorical cross entropy, guys. And then we will fit. How to fit, guys? We are fitting data, train images, train labels, right? Then epochs, and then batch size, right? So we are specifying that we need 50 epochs, and we are specifying that we need a batch size of 64. कल हमने बात की थी ये so oh, what's that? Okay, just a minute. I think we left something. Okay, did I complete it or not? Okay, just a minute. Let's take it. Okay, we are there. Then let's take it. Okay, and then let's take it. Okay, guys, right? So see, guys, we have applied 50 epochs, and now can you see, guys, the first epoch is taking place, right? Going on, because now we have a large data. We have 10,000 images, right, in the training. So obviously it will take some time for us to train the model, right? First epoch, then second epoch, then third epoch. I have gone through projects where it took around 24 hours to train the model. एक CNN project में it took around 24 hours to train the model, and the data was around 5 GB, or no, I think it was more than 5 GB. I think data was around 20 GB or 30 GB, and it was only possible, on the cloud only. It was not done on the local machine because we could not put the data even in the Google Drive, right? We could not put the data, right? Sergeant, for that, best way is that you should go to a documentation of the Keras, right? So the Keras documentation is very easy to simple, right? Easy to use, very easy, And when you go to the Keras, right, you have a very clear-cut understanding of everything, right? And here, you can talk about, let's say, so you can go to the guides, and there you have everything, right? So there you have code examples, and everything is there, you know so things would be very, can you see the sequential model? So you can go to the sequential model part, and in the sequential model now you have, right? So can you see, they are telling you that how to do that, right? How you can add the dense layers and everything, right? Creating a sequential model, and then specifying the input shape and advanced, right? And then we did something like that while printing the summary as well, right? And then we are also uh, doing something like uh, feature extraction with the sequential model it is talking about. So a couple of other things would be there. For example, you can see this. Can you see, guys? uh, Customizing what happens in the fit, you can go to this as well, right? And there you can see how to call fit and all. So everything is there. Can you see we are using the compile? Can you see it's optimizer as well? So you have a lot of things. So maybe you can talk about optimizer as well, Sergeant, and it will tell you a lot of details. Optimizers, can you go to this? And there you talk about what are the various optimizers, right? And here we see what are the popular optimizers. Can you see? Adam is one of them. RMS prop is one of them. You can go and check, a particular details from where to use NADM, AdamX, Adagrad, Adadelta, SCG. So a lot of optimizers are there, and we can go into the specific details of every optimizer and see where we can use it. So RMS prop is like this, right? And uh, uh, where it can be used, can you see? So a lot of details, and it's a very good site if you are interested in deep learning projects. I think it's a very handy guide for you, because everything cannot be taught to you. So some of the things you have to manage on your own as well, because if you don't understand how to take help from this, it would always be difficult, because काफ़ी सारी चीज़ें हमें खुद अपने लेवल पे भी सीखनी होती हैं. सो ये चीज़ यहाँ पे है. साजन, इज दैट क्लियर नाउ टू यू? So right, so guys, we are so can you see, still our training is going on, right? So training will happen, and after the training is over, you can see we are at 41 now, right? So after that, we can now start using this model for prediction, right? We can start using this for a prediction. So let's let it complete, and then maybe we can use one image to test. So let's see, we are at 45 now. Guys, चल रहे हो, जब तक ट्रेनिंग चल रही है तब तक बताओ कुछ मजा आ रहा है? Are you getting something? Right? Yeah, Ishika, that may happen, right? So Praveen saying, sir, I got 60%. I think that's a good number, right? Yeah. Okay. So, okay, cool. So, this is good, guys. So, now, see, okay, don't worry, you guys, you don't have to remember the syntax. Why you need to remember the syntax? As long as you are into good practice, you will always, you can always make use of Google, make use of any other site. रटना थोड़ी है, we have to understand the things, right? सिंटेक्स को नहीं रटना है, कभी रट भी नहीं पाओगे, और रटोगे तो कोई फायदा नहीं होगा उसका। ध्रुव, कॉन्सेप्ट को समझो। सिंटेक्स किसी को याद नहीं रखनी है, कोई फायदा नहीं उन चीज़ों। प्रैक्टिस होती है तो अपने आप ही आ जाती है, हमें कुछ करने की जरूरत ही नहीं है। सो दैट इज देयर गाइस। So just stay a minute, hold on guys. See, okay, guys, can you give me an idea that what is this 938 by 938? What is that? What is this 938? It starts with some number in the beginning, right? And then it reaches up to 938. क्या है ये चीज? What is this? Yes, 938 batches, right? Batch size तो 64 है. 938 batches, right? जो चाहिए to feed the complete data. That will make the one epoch. जब 938 batches पूरे हो जाएंगे, तब जाकर के एक epoch complete होगा, right? इशिका number of images नहीं, ये batch है, right? So after doing this, guys, let me use one image to test, right? Let me use one image. Let's see, we want to make a prediction that what is the label of this image which is at index 10, guys. What is the label of the image which is at index 10? So can you see, this is 28 by 28 by 1, right? एंड नाउ गाइस, आपको ध्यान है जब हमने अपने मॉडल को ट्रेन किया था तो हमने उसको इनपुट साइज क्या दिया था? 60,000, 28, 28, 1. दैट वाज द डेटा साइज, राइट? दैट वाज द डेटा वी हैड. यहाँ पे 60,000 इमेजेस जिनका साइज कितना? इतना. हमें उसी फॉर्मेट में ट्रेनिंग के लिए जाना होगा, राइट? द ट्रेनिंग का जो फॉर्मेट था वही टेस्टिंग का फॉर्मेट होना चाहिए. तो हमें इस सिंगल इमेज को भी उसी फॉर्मेट में कन्वर्ट करना होगा. सो वी हैव टू रीशेप इट. एंड कैन यू सी गाइस, द रीशेपिंग इज एग्जैक्टली सिमिलर. The only change that we have, because now we have only one single image, so instead of 60,000 we are using one here, right? So instead of, because we have only just one image, we don't have multiple images, right? Yeah. So this is there. Rohit, we are doing multiple, we have trained using 60,000 images, right? But we are making a prediction using one image only, but you can make a prediction with multiple images as well, right? And now guys, this data is with us. So can you see the test data is this? And now we can say model dot predict underscore classes test data. So now let's see what response we get. The response is this. It is saying that your image that you have given to me for performing the prediction, my prediction is label 3 for that, right? A label 3 for that. So guys, this way you can perform, a prediction on the single data as well, but you can use, a multiple images as well. Can you see guys? We will use, this test images now. Can you see? We will use test images. Why test images? Because test images are 10,000 nature. So we will perform the prediction here, and we can see the confusion matrix as well. Oh, we have to import it. So, and run it. What's that? Okay. See, do we need something? Okay, just a minute. That's there. That's there. Okay. So predictions will come. Okay, predictions are coming. And we need to check if this code is working or not. Okay, so we got it, and we have this print. Print matrix, it's Python 3, so I have to use this as well. Okay, fine. See guys, this is the confusion matrix. Why the confusion matrix size is 10 by 10? Can someone let me know why the confusion matrix size is not 2 by 2 or 3 by 3? Why it is 10 by 10? Because matrix का size वही होगा जितने labels होंगे. साजन गलती पे कर रहे हो. कितनी categories हैं data में? 10 classes. तो 10 classes हैं तो 10 by 10 की matrix होगी. Right? It's not dependent on nodes. It's dependent on the 10 classes. That there are 10 categories. मतलब मैंने 0 प्रिडिक्ट किया था और एक्चुअल में 0 था 976 केसेस. मैंने 1 प्रिडिक्ट किया था, एक्चुअल में भी 1 था 1127 केसेस. मैंने 2 प्रिडिक्ट किया था, एक्चुअल में भी 2 था 103 केसेस. मैंने 4 प्रिडिक्ट किया था, राइट? सो दिस इज ऑल देयर. So these are the correct predictions, but somewhere you can see, right? ये सब incorrect predictions हैं. यहाँ पे कुछ छोटे-छोटे नंबर दिख रहे हैं ना, 1 2 5 3 4 2. These are incorrect predictions. Only these are the correct predictions. Yes, Ishika, you are right. Right. So guys, that's it for today. आज के लिए हमारा ये था जहाँ पे हमने एक black and white images को यूज किया, MNIST डेटा को यूज किया to create a CNN model. अब कल की जो कहानी है वो सबसे ऊपर रहने वाली है, राइट? वो क्या है? That tomorrow I would be using a real data set, and that data set would be all of colored images. पहली चीज तो ये है, तो वो कैसे हैंडल करेंगे? दूसरा, सारी इनपुट इमेजेस डिफरेंट साइज की होंगी, तो उसको कैसे हैंडल करेंगे? यहाँ पे तो सारी इमेजेस 28 by 28 की थी. हाउ वी विल हैंडल दैट पार्ट, राइट? सो that something a very interesting part we are going to do tomorrow, right? Yeah, Souvik, we will create our own data set tomorrow. We will create our own data set tomorrow, guys, right? So this is there, guys. So आज की कहानी समझ में आई? कैसा है? How was the day today? Thank you, Abhay sir. Thank you. Thanks for being here. So So guys, Sylvester sir, please share the payment link. Guys, registrations for the deep learning certificates are open now. And Bharat, you have to keep your patience. Patience lose करने से कुछ नहीं मिलेगा. Dhoni is the best example. So या साजन, प्रैक्टिस के बिना कुछ नहीं होगा. ये पाइथन का ज्ञान नहीं है, इसमें बिना प्रैक्टिस के कुछ नहीं चलेगा. सो गाइस, a payment link is open now. People including Bharat have already paid for the certificate, and yeah, Praveen, that will happen. Yes, Bharat, a lot of people have already paid. So guys, go and register for your certificate, right? So this is there. Yes, Ishika, you're right. We get a notification, Bharat. So that would be there. So guys, देखिए डीप लर्निंग में या किसी भी जो थोड़ा एडवांस टॉपिक्स होते हैं, तुम समझ सकते हो कि यार पाइथन वाज इजी टू अंडरस्टैंड, राइट? उसके बाद डेटा एनालिटिक्स अ लिटिल डिफिकल्ट बट अगेन इजी टू अंडरस्टैंड. उसके बाद मशीन लर्निंग आर डिफिकल्ट, राइट? Difficult than learning Python, difficult than learning analytics, but deep learning is above all, right? So obviously you have to put a lot of efforts and you have to have a lot of background, right? You have to have a lot of background. Some of people have directly jumped from Python course to deep learning. For them, it would be a kind of a difficult situation. They will struggle to understand the things. Even people who have gone through AI and ML course, they are struggling. So, you can easily understand that it would be really difficult for someone who is jumping directly from Python course to deep learning here, right? It is kind of a mess in that case. Rohit is, I think, there. That is the case, right? But Rohit, don't worry. जितना समझ में आ जाए उतना अच्छा है. 30%, 40%, 50%. So later on, you can leverage that learning, right? For later case. कई बार हो सकता है तुम्हें वापस से वीडियोस को देखना पड़े या कोई प्रोजेक्ट बनाना पड़े. But still, the things that you are learning here, they will really help you, right? At least they will reduce your time, right, in project implementation, because you already know they are on YouTube, Bharat, right? They are on YouTube. So guys, then see you tomorrow at 4 p.m., right? So कल वापस से मिलेंगे, right? स्पाइडर और कोलैब में कुछ अंतर हैं, right? Yeah, Bharat, that is a good idea, right? Boosting is a algorithm, Avinash, right? And lot of Kaglers use that boosting, algo. So I think better if you search on the Google around this, right? That will help you. A lot of people use boosting in their projects. Yeah, bagging and boosting, guys. They are used in decision tree as well, right? Yeah, Ashi, thank you. Ashi, what is your college and your which state you belong to? From where you come? Where you come from? Ashish, it's 500. Niranjan, it is not related to CM. LSTM is RNN. I will talk about that on Saturday. RNN. So LSTM is a specific implementation of RNN, but no, not related to CNN. Okay, Bharat. Good. So, guys, thank you. See you tomorrow. Bye bye. Take care.